Okay, so here we're doing systems of inequalities. So we have this wonderful word problem. We're dealing with the Wheel Cycle Company, and they're going to manufacture motorcycles and bicycles. And to stay in business, they have to produce at least 10 motorcycles a month. So we're going to let M equal to motorcycles, and B is going to be bicycles. Real original, right? Now the first sentence tells me what? M has to be at least 10. So that means I want M to be greater than or equal to 10. 10 is the smallest number we can produce. And then it has a but. It does not have facilities to produce more than 60. So if it's not more than 60, then it has to be less than 60. Opposites. Easy enough. Okay? Now next sentence, let's look at the bicycles. The bicycles, they cannot produce more than 120. So if it's not more than 120, it has to be less than 120. Okay? And then total production cannot exceed 160. So if it's total production, that means I'm adding the two of them together. M plus B equals to 160. All right? Then they give us this great information that tells us the profit is $134 for a motorcycle and $20 for a bicycle. Now the profit is actually extraneous information. We really don't need that in order to work our problem. So one of the things we're asked to do is write the system of inequalities. We just did that. We have these four beautiful inequalities. I put equals to. That's a problem. Cannot exceed, which means it must be less than. Not equal to. Must be less than. Okay, then they want us to graph it. Here's where you get to have a little bit of fun. You get to pick which axis is going to be M, which axis is going to be B. So I'm going to put my motorcycles right here. Okay, and then I'm going to put my bicycles on the y-axis. So I have my x and I have my y. Okay, notice my x goes from 10 to 60. So I have one line at 10 and one line at 60. I cannot go outside of those lines. All right? So inside is the only part we can do. Then it has to be less than, on the bicycles, 120. So we're going to say that this is 120 up here. So I know my drawing's not to scale. And that marks the high. So it has to be anything below that line. So now I have a box. Now you say, well, it could keep going. Well, here's the problem. Can we produce a negative number of bicycles? No. So we have to stop at 0. We cannot go below the axis here. Okay? My last equation, the trick is how to put that on the graph. Well, B is my y. So if I put this as y plus x less than 160, and we were to solve that for y, what would we do? We would subtract the x. Okay, so I would have y less than 160 minus x. So I would come up here to 160, right? And my slope is going to be negative 1 over 1. So we would draw a line, negative 1 over 1, all the way down the graph. Okay? Now it says less than, so I know that I'm going to be in this region right in here. Okay? Now one of the things they ask us to do is define a reasonable domain and range. So remember, domain is our x values, and our x's, in this case, is the motor. So the motors can be from 10 to 60. My range is what? My bicycles. And the lowest value I can have is 0 because they didn't give me a minimum. My highest value is 120. So we're not going from infinity to infinity. Now the last thing they asked us to do is identify 3 possible points that would be solutions. Okay, so possible solutions has to be a number in between 10 and 60. So let's pay 35 motorcycles. And any number between 0 and 120. I'm going to say 62. It doesn't matter. That's one possible solution. Okay? You could have picked the highest because, of course, you want to make the most money. So you could have produced 60 motorcycles, right? And 120 bicycles. Well, here's the problem. Is that inside the shaded region? That dot's out here. Is that inside the main shaded region? No, it's not. But if I go to 35, 62, that's right about there. It's in the middle. So we need to pick some smaller number than that. Okay? Well, you say we could go right in here somewhere. Okay? So I could do, let's say, 100 bicycles and only 20. Okay, so as long as we stay within that main shaded region, it doesn't matter which numbers we pick. Now, obviously, depending on the numbers you pick as to the profit you make. So that's where our profit equation would come in, is when we would want to optimize it for the maximum amount of profit, which we are not going to do in this problem.